Okay, I bet that last video was longer than 16 minutes, so again, just watch for the divisions. At least they'll be in the order I gave them. Okay, autosomal recessive inheritance. Remember, that is involving autosomal chromosomes, so 1 through 22 in us. Recessive, the individual with the two recessive alleles, or in the case of sickle cell anemia, 2 S's, ends up with the disease. So let's do cystic fibrosis as an example. And I mentioned that most of us, if not all of us, probably do not carry the allele for cystic fibrosis. I'm going to use L for the allele. Big L for normal chloride transport protein. And little l, I'm not going to use the C's, that's why, so I'm going to pick the L for the abnormal, the one that doesn't work. Normally we'd have some idea that cystic fibrosis was running in our families because somebody in our family might have cystic fibrosis. Not always, but sometimes. But let's say there are 2 people, they have no idea that they are carriers. So the carriers are big L, little l, and they have no idea. So, but they decide, hey, let's have a baby. And there's a good chance that they will not have a baby. 75% chance. No cystic fibrosis. That's pretty good. There's a 25% chance that the child will have cystic fibrosis. So, what if they do have that child with cystic fibrosis? Now they know that they are both carriers, that they have those little L's. They don't have cystic fibrosis, but they know they carry it. Let's say they want to have another child. They have the same probability with the next child, 75% versus 25%. My understanding is that there's a family somewhere locally where they have 3 kids with cystic fibrosis. So they hit this 25% 3 times. But one thing they can do, because right now we can't do the gene therapy, someone asked, why is that illegal? It's illegal because we're not sure what people would do with it. Think about Botox. Botox was originally developed as a treatment for problems with vocal cords. When vocal cords would contract or not contract or something, but there was something wrong with the vocal cords, and they used it therapeutically. Now it's for cosmetics. If we allowed for this type of research for therapeutics, how long before there's designer babies? I want you all to read about germline and somatic cell gene therapy. I want you to look that up online. I want you to look at those issues. But there are issues with germline that there aren't with somatic cell. Another thing you can do is you could have in vitro fertilization. In vitro IVF, in vitro fertilization. And then what they do is they give the woman hormones, they harvest multiple secondary oocytes, they then use the husband's sperm to fertilize those, they grow them to a certain stage, they pick off cells or a cell, they grow that cell, not the embryo now, not the product of conception, but just a cell, so they have a cell culture. They grow that, they find out then what they can actually test for this abnormal allele. If they ended up with 6 embryos, and 3 had only the big L's, or the big L, little l, and 3 were little l. They just don't use those for possible fertilization. That's pre-implantation diagnosis. Not every religion would be okay with that, because what do you do with these embryos? Okay. Don't have time to get into that too much. Sex-linked, okay? It's on the X chromosome. So, let's do factor VIII deficiency. A mom can be big F, having 2 alleles for making factor VIII, or she can be big F, little f. Okay? Both of these ways equal normal clotting. Okay? In order to have abnormal for the woman, she would have to be like this. And that may become more of an issue as the males with hemophilia live longer. And they're living longer. A male, on the other hand, is like this. Okay? He doesn't have 2 alleles. He cannot be like this. And this is complete dominance. So the normal allele for factor VIII is completely dominant over the recessive allele. Okay? So, we go from, in general, maybe a 75% chance of not having hemophilia to a 50% chance. And again, before modern times, these boys were dying as children, so they weren't making children. So we certainly weren't seeing a lot of this. Okay? So let's look at what that Punnett square looks like, because it looks differently. We have to put the X's and the Y's in. So let's say mom is a carrier. So she's this. Okay, she doesn't have the disease. She clots normally. Dad doesn't have the disease. So they go to have babies. None of their female children have it. Half of them are only normal allele. Half of them are carriers, like mom. But nobody has hemophilia. They're sons. Half of them don't have it like dad, but half of them do. I had a student in class. There were 4 kids in the family. Mom was a carrier, and her sister didn't carry it. She carried it. One brother didn't have it. One brother had it. Crazy, huh? Again, things are changing, and people are living longer, so there is a possibility. Look at this. So, again, mom's a carrier. Let's say dad has it, and that couldn't be hidden. They would know he had it. With that, one of the females is a carrier. One has it. We still have a male who doesn't have it, and we have a male who has it. So 50% of the males, 50% of the females would have it in this case. But here's what I'm guessing. Any male with this hemophilia is probably urged either not to father children or pre-implantation diagnosis so they can make sure that their daughters don't have it. And again, we might be able to do gene therapy. Autosomal dominant. Now, Huntington's disease. This is associated with Huntington's disease. So, homozygous dominant and heterozygous has, whoops, that shouldn't be an F, has Huntington's disease. Only little h doesn't. So, there's a chance that all of us are little h. I'm close to 60. I think I'd know if I had Huntington's disease by now, plus there hasn't been any in my family. I mentioned Woody Guthrie in my other lecture. Woody Guthrie's mother had it. They didn't know until she'd had children, and she went a little berserk and burned the house down. And that's when they realized that something wasn't right with her. And eventually she succumbed to the disease. All right, so Huntington's disease. You can see how now this is really worse. So if someone has just one allele for it, they're heterozygous. Babies. Baby making time. Looking at the probability. Look at that. 50% chance of passing that allele down. That ain't good. Okay? So hopefully going through these helps you. I'll put some other materials up like Khan Academy that can also help you with these monohybrid crosses. We still have a dihybrid cross to do, but I'm going to stop now and find out how much time is left on the camera battery.